Hey, what's up, everybody? We're working on the single replacement reaction section here. So I'm going to record a couple of demonstrations for you. Take a look at them, and as we go through this, I'd suggest making some notes, and I'll try to get everything that you need to make sure you can do this. So the first one, we're looking at hydrochloric acid and magnesium. This is reaction H, and inside my test tube, you can see clear, colorless. There is a little bit of a smell to it. Not something that I'm going to shove up my nostrils. That'll hurt. I mean, this stuff really does have some odor. But clear and colorless, and that would be the hydrochloric acid. And then in my hand here, you can see there's a little tiny piece of magnesium. I don't know how well you can actually see that, probably because I'm backlit really nicely. Nevertheless, it's a gray strip that I kind of balled up. And what we're going to do is we're going to go ahead and place that right inside. All right, you can see that there are bubbles and there is steam coming straight out of that. I can hear the bubbles and the fizzing. It's very distinct. I don't really have any smell coming from the steam or the gaseous vapors coming off there. Oh, I can definitely touch it. That's definitely warm to the touch there. So now that I look at the magnesium, it is gone. You can see there is no more magnesium strip inside of there. And so that would be your first demo for reaction H, hydrochloric acid and magnesium. We started with a clear colorless liquid and a grayish strip of metal, ended with another clear colorless liquid. We had some heat that was generated. We had some gaseous vapors that generated, some bubbles that were generated. So that should be enough for you to be able to do reaction H. For reaction I, we are mixing zinc metal, which are these crusty chunks of metal here. You can see that they are, it's almost like coral the way that that looks, but they're sharp, chunky pieces of metal, grayish in color, and we are mixing them with lead nitrate. Lead nitrate is clear, colorless, not a lot of odor, nothing coming off of any of those. This one you had to let sit for a while, so we put it in and have let it sit for quite a while. And you can see the chunks are in there mixed with the clear colorless, but as I mix it around, you can see that there's little tiny particulate matter. It's very different looking than it was before. There's a little bit shiny pieces inside there. There's still a few of the chunks of metal that are around, but a lot of the metal has kind of turned into almost dust. That would be the consistency of that. I don't see any heat created or any gases being released at all, but there is that change of color is a little darker, definitely darker. There's some shiny pieces in it. It's very dusty like. That should take care of your zinc and lead 2 nitrate, and that is reaction I. And then we have reaction J, which is sodium and water. Inside my beaker, you got the water. All right, and then inside, I'm going to drop with my scoopula. I got it picked up in the scoop. You can kind of see it's like a whitish, silverish metal. You can see there's a little bit of mineral oil on it. That's because sodium metal is highly reactive with water, even including what's in the air. But I'm going to go ahead and drop the sodium metal right into the water, and you can check out and see what happens. So hopefully you guys will be able to see that. Let it kind of go. I'm going to back up a little bit here. Oh, there it goes. You can see that there's gases being generated, obviously heat being generated. It's on fire. I can hear it. It's a big time sizzle sound going on there. Lots of sparks and little things going on. It's almost dancing over the top of the water. I don't know if you can kind of see it zooming around in there. I can see it in the camera a little bit. But that's still going. Apparently I put a decent sized chunk inside there. You can see the sodium itself, that metal is pretty much gone. It's dying off as this starts to slow down. You don't really see any of that chunk of metal that was there before. It used to be that it was size of maybe like a couple of little green peas stuck together, and now it is just about gone. So there's your 3 reactions for single replacement. And obviously, if you have a question, let Mrs. Whiteford or myself know, and we'll help you out.